Hello everyone, and welcome to another math tutorial. This video is going to be the first video in a geometry unit, typically chapter 1 or unit number 1 in a geometry text. The title of this lesson is called Points, Lines, and Planes. These are what we call our undefined terms in geometry. There are basic building block pieces that we'll use to kind of build other more complicated things. So in this lesson, we're going to learn how to identify and name points, lines, and planes. We're then going to extend those to segments and rays, and we'll go over how we can make some sketches of some of these things as well. Okay, here we go. All right, let's get started right away with our undefined terms, and there are 3 of them. The first 2 are on this slide here. The first undefined term is a point, and a point very simply has no dimension, and we represent a point by a dot. You'll just see a physical dot. And so if I can draw one for you, there's a point, and typically we're going to name the point, so let's just name this point P. So there'll typically be some letter of the alphabet associated with every point, and if we were to name that point, we're actually going to physically write point and then P. Whatever the letter is that names it here is going to be written there. Okay, next let's talk about a line. A line has one dimension. It's represented by a line with arrows on both sides, and it extends without end in both directions. So a line might look something like this. Now a line, we'll learn later in a theorem, has to contain a couple of points, has to contain 2 points. So let's put 2 points on the line. Typically you put them out near the end, kind of by the arrows, but they can go anywhere on that line. And then we need to, since those are points, we need to assign any sort of letter that we want to them. So let's just call this point A and point B, okay? Now, if we were to name this line, with these 2 points, there's 2 ways that I can do it. I can write the 2 points A, B, and then I'm going to put a line above it, or I can switch the order of those points and put B first and A second. So I could call that line AB or line BA. Now the other way that you're going to see lines named, so sometimes you'll see lines that look like this, and they don't put points on the line for you, but they might name the line a little bit differently. So out on either end of the line, it doesn't matter which end, you might see a lowercase letter. So maybe we see letter K on the end of that line. And then we can name the line a little bit differently. I could write this as line, actually use the word line, and then K. I'll pick the letter that is assigned to represent the entire line. Okay. What I don't want to do is mix these up. Okay. I don't want to write line and then choose one of the 2 points. And I also don't want to write the word line in front of this notation. So you're either using the symbolic notation like this, or you're naming the line based on the letter associated with the line. Okay, our final undefined term is called a plane. A plane has 2 dimensions. It's represented by a shape that looks like a wall or a floor, and it extends in all directions without end. So you can think of the piece of paper that you're writing on as a plane, or maybe the desk surface that you're writing on is a plane. Any sort of flat 2-dimensional surface is a plane. Now typically in a picture we represent a plane almost like a parallelogram. You'll see very often something like this. Okay. Now there are 2 ways that we can go about naming a plane. The first way is you're going to need some points. So let's throw some points in here. Let's call this point A, point B, and point C. If you're going to use points, you need 3 of them, and those 3 points cannot be in a straight line. They have to be what we call non-collinear points. So if I see those 3 points and they're not in a straight line, I can call this plane A, B, C. The order that we put the points right there doesn't matter as long as we preface it with the word plane. Now, like when we name the line, sometimes we can name planes differently. Sometimes they'll just be a single letter that's not a point, but a single letter that defines or describes the plane. So let's put a letter out here, and typically you're going to see it in one of the four corners. So if I just saw that and these 3 points were not there, or maybe they are, but they wouldn't need to be there. If I just saw that letter there and there's no dot, so there's no point there, I could just call this plane Q. Okay. Either way I name the plane, I am actually writing the physical word plane in front of how I name that, or whatever points or letters I end up using there. All right, this first example problem is going to just review those 3 undefined terms and give us an opportunity to practice naming and identifying these terms. So here we've got a diagram here. I see this plane, and I see that there's a line inside the plane right here, and I see there's another line and the dotted line indicating that that line is above and then below the plane. So that line right there goes right through the plane, whereas this line is actually physically on the plane. Okay, so our first question here, give 2 other names for line CD. Line CD is this one right here. So one way that I could name it is I could simply just take the letters CD and I could change them, the order of them, to DC. I could just flip those letters. The other way that I could do this is I could use this letter M, which is out on the end of the line. It's not a point, but I could use that to name it. I could call this line M. Okay, so those are the only 2 other ways based on the information on that picture that we can name that line. Next question, give another name for plane M. Okay, so the plane is this 4-sided shape, M in the bottom corner here, indicating that that's the descriptor for that plane, so we can call it plane M. Now, since we've used this way here in the problem, I have to use the 3-point method. So what I want to do to name this, I'm going to write the word plane, and now I need to pick 3 points to go with this. And the points that I pick cannot be on a line. Okay, so I don't want to look for points like that. Okay, those 3 points would be collinear on the same line. I need points that are not on the same line. So I need something, take that off. I need something like that instead. Okay, 2 points can be on the line, but the third one can't be in a line. And so what I see in this plane is points A, B, and C on this line. I'm going to pick 2 of those, and then I'm going to pick point E as well. And it doesn't matter which 2 of these I pick, as long as I don't pick all 3 of them. Okay, so we could call this plane A, C, E. That would certainly work. I could do plane BCE, or I could do plane ABE. I could mix the order of the letters, but something like that would be an appropriate name for plane M. What I can't do is I can't pick point D, because point D is not inside this plane right here. Okay, next question. Name 3 points that are collinear. Collinear means on the same line. So pick 3 points, or name 3 points that are collinear, and then name a 4th point that is not collinear with these 3 points. Okay, so the only points that are collinear, there are 3 of them, are the ones on this line right here. So I would say point A, point C, and point B. Those 3 points are the collinear ones. Name a 4th point that is not collinear. I would say point, and now here we have options. I can choose E, because that's not on the line, or I could choose D, because that's clearly not on the line. Either of those 2 would be an appropriate choice for the 4th point. And then finally, question number 4 here, name a point that is not coplanar with points A, C, and E. So coplanar, if collinear means they're on the same line, coplanar means they're on the same plane. So I want a point that is not on the same plane as A, C, and E. And the only point that's not on the same plane as A, C, and E would be this point D, which is above it. And there we go with those example problems. Okay, next we're going to go over a few more geometric terms. These I just changed to defined terms. We started with the undefined terms, which are point, line, and plane. You're going to see those terms used within the definitions of these terms. So our first one here is a segment, and you see a segment is a line. So we're pulling that undefined term line. We see this other one here, point. So we see some of those undefined terms used within here. Segment is a line that consists of endpoints. So that's different. Endpoints, it's not going to continue on forever. And all the points between those endpoints. Okay, so a segment might look like this. So instead of seeing arrows on the end and then the thing going forever in both directions, we just see a piece of a line that's then kind of like chopped off. So we have endpoints and then we have all the points that are between those two endpoints. Now, when we name a segment, we again need to know the names of these endpoints. So let's just call these M and N. And I'm going to name this very similar to how I name the line. I'm going to use those two endpoints. And above them, I'm just going to do a segment bar. Notice the difference between the line and the segment is I don't put arrows on the ends. If I put arrows on the ends, then it means something different. I could, of course, also change the order of those points and call it segment in M. Either of those two would be appropriate name for this particular image. Okay, the next term is a ray. A ray is a line that has one endpoint and it will extend forever in one direction from that endpoint. So a ray might look like this. There's an endpoint and then the arrow on the other end indicating that it stops on this point and it goes forever on this end, so without end over here. Now, when we name a ray, just like with lines and segments, we need 2 points. So we've got this endpoint here. Let's call this endpoint A, but we need a second point. The second point can be anywhere on this ray, but do not put it at the end of the arrow. I see some students do that. Don't put it there. Put it anywhere on the line part. Let's call that B. Okay, so we've got points A and B, and then the ray extends through B, and it just keeps going that direction. Now, when we name a ray, you want to name it so that the endpoint is listed first. So the endpoint is point A, so I'm going to call A and then B. And then above that, just like with lines and segments, we're going to put just a little ray above. So we're going to go like this. Okay. Notice that the end of this little miniature segment is over the A like it shows here, and then the arrow is over the B, indicating that it's going through point B. Okay. Even if you see your picture of your ray going other directions, so let's say we start here, and this is still A, and this is still B, this is still the correct way to name this ray. Okay. What we're not going to do, okay, so let's write this out because I see this sometimes. Do not call this ray AB that way. Okay, the mistake in this is that we don't want the arrow pointing to the left because when we read, it's pretty natural to read left to right. That's how we read. So if you read this, you might incorrectly read out loud. You might say ray BA, and if we say out loud, if we say BA, then we are indicating that B should be where the endpoint is and A should be where the arrow is. So we're not going to do this. We're not going to make our symbol go to the left but we instead always want it to go to the right, even if it pictures the other direction. Okay, I hope that was clear. Let's move on. Okay, sometimes you hear the term opposite rays. It might show up in text or in a problem. And very simply, opposite rays are two rays that share a common endpoint. They create a straight line, okay? So opposite rays may simply look like this. You've got, here's a ray like so. And then we have, let's call this PQ. So here we have ray PQ. And then we need another ray that goes in the opposite direction. It has to go from the same, right? They're going to share, it has to go from the same endpoint. So from point P, we need another ray. I could call this point R. So now we have ray PR. Okay, so there's a pair of opposite rays. They both share this point P, and they go in opposite directions from that point P and make a straight line. Okay, in this example problem, we've got a diagram. It looks like a couple of lines that intersect. The first question is to give another name for line PQ. So line PQ is this one right here. We can see on line PQ, those are the 2 points that we had. So we could name this line QP. There's also this point T. There's no physical dot there, but the intersection of those two lines is a point. So we could use point T in our name. So I could do something like PT, or I could do QT, or I could flip PT and QT, the order of those letters. Or I could also use this letter out at the end, and I could just call this line J. There's lots of possible answers for that particular question. Okay, next, give all the names for line RS. So line RS is this other line, and same sort of question. We've got RS, we could just flip the letters. I could use point T right there. I could use the K on the end. Now it wants all other names, so we need to list them all here. So I've got SR, just those two letters flipped. I could use RT, or I could change the order of RT to TR. That's the same line. I could use ST, or I could change the order to TS. Okay, so all those are fine with those 3 points. I could also use K, and I could call this line K. Any of those would be appropriate names for that line, and that's all of the names for that line. Okay, the final question here wants name the opposite rays that make up line J. So line J, let me just draw it here. Line J is this line. Name the opposite rays that make up line J that share the common endpoint T. So starting from T, I could go this direction through P, or starting at T, I could go this direction through Q. There's our opposite rays on that line from point T. Okay, our final example problems are asking us to make some sketches of some things, some descriptions that we're reading. This is a pretty common exercise to do. So here we want to sketch a line named K that is in plane Q. So when I make this sketch, I'm going to start with plane Q. So I'm going to draw myself a plane. You can draw it to look like whatever you want. I'm going to make mine kind of like a parallelogram. Now to be plane Q, it's got to be named plane Q. If I don't put that Q there, then I haven't technically drawn plane Q. Now I need to put a line inside of this plane. So line K can be anywhere inside here. and I have to name it line K. So there is line K inside of plane Q. Okay, the next one wants me to draw a segment. Okay, so notice you have to look very closely here. Notice what this looks like above the letters. Okay, so this is a segment AB, and ray, that's got an arrow on that end, ray BC. Okay. Also notice that in the naming, I've used the letter B or point B there, and I've also used point B here. So point B is shared between those two, segment and ray. Okay, so let's go ahead and do that. I'm going to start with the segment. So draw a segment, label the endpoints A and B. You can put B over here and A over here, it doesn't matter. But there's my segment AB. Now I need to draw a ray BC. I've already got point B in the picture. Okay, so don't come like out here and draw yourself a ray. We have to use that point because it's listed right there. So in any direction you want, we need to draw a ray BC. So that would work. But that ray can go out in any direction that you want it to go, and it would satisfy this description. It would be just fine. Okay, this last sketch that we're asked to draw needs a line M and plane P that intersect at one point, and that point's name is point H. So I need a line and a plane. I'm going to start with my plane P. So again, I like the parallelogram look of these planes. So that's plane P, done. Now I need a line M. So I need a line that, and it can only intersect the plane at one point. So I don't want to draw it inside the plane, okay? Instead, I want to illustrate that the line is above the plane and it passes down through the plane to the opposite side. So the line has to be like above and below the plane. And the way I'm going to do that is like that. So the dotted line used right there is illustrating that at that point, that line is behind the plane. It's on the other side or even the underside of that plane. Now that line is named M, so I need to put M on the end either here or here, it doesn't matter. And where this line intersects this plane, that point right here is point H. Okay, and that would be an appropriate sketch of that description. All right, that concludes section 1.1 in this geometry playlist. If you have any questions or comments, please leave those below. If you liked this video or found it helpful, please give the video a thumbs up, and I'll see you in the next one.